All right, so this is the recorded review session for exam 3. If people pop in, I'll let them ask questions, but I'm assuming most probably won't due to possible Wi-Fi issues because of the storm. Okay, so what I'd like to do is work through the WebAssign homework. So number 1, so this is 3.1, number 1 says the quadratic function. So we've got f of x, and they've given us a generic form here, a times x minus h. This is a generic standard form. So they say is in standard form. The graph of f is a parabola with vertex, which is an xy coordinate, is equal to, well, if it's in this standard form, then its vertex we know is h comma k, reading from the h and the k there, h and k, flipping the sign on whatever's happening in here, right? So if it's an x minus 2, that means a 2 goes in there, but holding the sign on the k. If it's a positive 2, the 2 is positive there, etc. If a now, so now looking at a, so we've identified what h and k tell us. If a is greater than 0, then the graph opens upwards. The graph of f opens upward. The graph of f opens upward. Meaning the legs are pointing up. That's how I've been describing that. And then in this case, f of h comma k, let me write it down. F of h equals k, which is just saying this coordinate point, right? At this input of h, you get an output of k. That's just describing this point here. Is the minimum or maximum if the graph is opening upward? Well, if it's opening upward, then this vertex is the minimum. Similarly, if a is less than 0, the graph of f opens downward, the legs are pointing down, and that vertex f of h equals k, that coordinate point is a maximum. Okay, is a maximum point. Right, because if the graph is pointing up, then it has a lowest point right there, and if the graph is pointing down, then it has a highest point right there. And this f of h equals k is just another way of writing the vertex h comma k. It's just another way of describing this coordinate point, saying plugging in an input of h, getting an output of k. Input of h gives an output of k. Right. So number 1 is more like a definition thing, right? Definition of standard form, understanding how to pull the vertex out and what the letter A does for you. Number 2 is applying this now. So we get so this is number 2. We have a function f of x equals -3 times x minus 2 squared minus 7. And we have to say if it opens downward or upward. So since the a term is -3, it's negative. So this graph opens downward. And its vertex is at looking at the h value, it's going to be 2, and then the k value is -7. And this means f of 2 equals -7, right? That's just another way of describing this point, like I said before, is a maximum or minimum. If the graph opens downward, then that vertex is a maximum. Good. So this is pretty much the same as number 1, except just with some numbers plugged in instead of just generic a, h, and k. Now, number 3 is a bit more interesting because it's not given in standard form. It's given in, what do I call this? Just a normal form. So this is number 3 in the 3.1 WebAssign. It's given in this normal polynomial function form, so it's not factored and cleaned up for us. It's not in that standard form. So first thing we have to do, well, what are we asked for in this question? We're asked for the vertex, we're asked for the x-intercepts, we're asked for the y-intercept, we're asked for whether the vertex is a max or a minimum, and what the minimum or maximum is, and we're also asked for the domain and range. All of that is going to be way easier if this function is in vertex form. Or standard form, sorry. I like to call it vertex form because that makes more sense to me, but we want this function in this form. So how do we do that? Well, there was a process to this, so here we go. Just buckle in because it is quite a process. So here we go. So first of all, you write the function down. Okay, first thing you do after writing it down is factor any number off of, if there's a non one leading coefficient, like in this case there's a 2, it's not a 1, right? It's not just a 1. Then you have to pull that number off of the first two numbers, the first two terms, I should say. So we're going to pull that 2 off, leaving me with x squared minus 2x, but we're only pulling it off of the first two terms. Leave that constant term at the back alone. Leave that term alone. Then what we do is we take half of this linear coefficient and square it. That's like the weird side work that we do. And I'll admit this process is weird. We could justify it by proving it, and we would actually come to a very nice conclusion if we did that, but let's not bother with that. So we're going to take half of the linear coefficient. Now I need to identify what the linear coefficient is. Well, inside here it's a -2. That's the linear coefficient. It's the number coefficient attached to the linear term. The linear term is the term that's just has an x, not x squared, not x cubed, not a constant, just the x term. This is the linear term. And we want the linear coefficient after the number has been pulled off. So we want the -2. So we're going to take half of that, which just means dividing it by 2, right? Half of means divide by 2. And then squaring it means, well, squaring it, right? Raising it to the power of 2. So if this can be cleaned up, go ahead and clean it up inside the parentheses first, and then you're going to square it, and that's going to give you a 1. That's what gets added and subtracted to this function. That's what gets added and subtracted to this function. But remember, there's a bit of funny business that can happen where the thing that gets added or subtracted outside the parentheses looks a little different. So here we go. This is where we are right now. We're going to add that 1 right here. And then I need to make up for that by subtracting 1 out here, except it's not just a 1, right? We have to be a little bit more careful and say, oh, wait, what did I actually add to this function? Because now I need to zoom out and think about bringing balance to this whole function, not just bringing balance to the part inside the parentheses. Well, technically what I actually added to the greater function is a 2, right? Because this 2, if I expanded this all back out, this 2 would hit that 1, making it a +2. So I need to bring balance to this function, not just by subtracting 1, but by subtracting 2. All right. That's one of the tricks to this. The kinds of these problems that have a leading coefficient that's not a 1, they tend to be a lot more tricky, not just because of this step where you have to factor that 2 off of the first two terms, but also because of this step where you have to remember that that 2 is out there and that it's going to affect whatever you added inside your parentheses, affecting what you need to subtract to bring balance to the function. So they are much trickier when they have a number up front that's not a 1. So now at this point, the idea is that you factor this thing, x squared minus 2x plus 1, into a nice compact squared polynomial here. And how do I know what it looks like? Well, it should look like x minus 1, where the minus 1 is coming from whatever was inside the parentheses here, the half of that linear coefficient before you squared it. This number gets stuffed in there next to x. Or you can just go off on the side and just factor it by like traditional methods, like the x squared minus 2x plus 1. Two numbers that multiply to give 1, that add to give negative 2. Well, I think that minus 1 would have to do it. Minus 1 times minus 1 is 1, and then negative 1 times negative 1 plus negative 1 is negative 2. And then I have to remember that this can be written compactly like that. So you can go off on the side and factor it. And they'll always, if you've done your work right, they'll always factor into a nice compact form like this. Okay. So now what do I need to do? Oh, I need to take care of this out here. Minus 3 minus 2, that's minus 5, right? Minus 5. Okay. Look, it's in standard form now. So this is really the brunt of the work, right? Well, finding x-intercepts can be kind of involved too, but I think this is the hardest part of this problem, is getting the function into standard form. But now we can find all the stuff they want us to find quicker. The vertex is going to be 1, negative 5. Just because I know how to read the vertex from the standard form. That's the h value, that's the k value with its sign there. So I'm flipping the sign on whatever's happening in here, right? If it's minus 1, it becomes a 1. If it was plus 1, I would write negative 1, right? So always flipping that sign on the thing happening inside the parentheses, but holding the sign on the k value, the thing happening out here. So there's my vertex. Okay. Now they ask for the x and y intercepts. Before I get to that, though, let me go ahead and say that the graph, which way is the graph opening? It opens upward. Look at that 2. It's positive, so the graph opens upward. So the vertex is a minimum. And then the way they ask this question is they say, find the maximum or minimum value of f. So you would select minimum. And then they say, the minimum value of f is, and then they say f of x equals. So they're asking for the y value. Because remember that the technical way to describe the minimum really is to say that the minimum of this function, f of x, is equal to negative 5. The actual minimum value is the y value, the output, and it happens at x equals 1. Okay, so how you describe the minimum or maximum depends on how they ask the question. You have to look at how they're asking it. Are they asking explicitly just for the y value, which is what they're doing in this problem, number 3 in the WebAssign? Or are they asking for the full coordinate point, which is kind of what they did in number 1 and 2? Are they asking you to write it in this form? Are they asking where the minimum is happening, or maximum, depending on the function? So, you know, as long as you have the vertex, you have the information. You just need to make sure that you know what the way that they're asking for it. All right, so now let's answer those questions in between. Oh, wait, no. We can do one more thing here off of this minimum. Let's talk about the domain and range. Recall that the domain for all of these functions that we're dealing with in this chapter is just completely unbounded, will always be negative infinity to infinity. The range, however, is bounded, and it's going to be, if you've got a minimum value, then that cuts off on the left, right? That's my minimum value, and I do not have a maximum value. So if you have a minimum, then it cuts off on the left, right? That's the lowest the y value can ever be. Because remember, range is the set of y values that are allowed in the function. I think they also give you a graph of it, so you could see that minimum y value happening on the graph too. Yeah. If you have a maximum, then your range would look like it would be like unbounded going to the left and then like bounded by some maximum on the right. That y value of the vertex would be on the right there. That's if you have a maximum. In this case, we had a minimum. That's why it looked like this. Okay, so now let's go answer these questions about intercepts, about x and y intercepts. So again, the function was f of x equals 2 times, and yes, I'm using the standard form still. Finding x-intercepts means set the function equal to 0 and solve for x. Remember that sometimes things can get a little tricky here, or they can get a little messy if you end up trying to square a negative, right? If at the last, so this step here, where what have I done? I've added 5 and then divided by 2, right? That's all I've done to get from here to here. Now at this point, if I take my square root and this thing is a negative, then that means there would be no x-intercepts, and you would type in like does not exist, like DNE, into the solution. But in this case, it is positive, so I can take a square root. So my next step is going to look like plus or minus. Don't forget, when you do take a square root, you put plus or minus on the outside. And there's that. And then when you add this or subtract this last little piece here, you stuff it right there. So we would say x equals positive 1 and then plus or minus square root of 5 over 2. So those are my two x-intercepts. And they do ask us to round our answers to 1 decimal place. So we could go to the calculator and say, okay, x is equal to 1 plus square root of 5 over 2, or x is equal to 1 minus square root of 5 over 2. So that's going to be approximately, so let me see if I can get this glare to, all right, I think this is okay, like here. So I would say 1 plus and then square root of 5 over 2, close parentheses, 2.6, rounding to 1 decimal place. And then I would say 1 minus square root of 5 over 2 is giving me negative 0.6. Okay, so my two x-intercepts are negative 0.6 comma 0 and 2.6 comma 0. And then in the WebAssign, they ask you to put the so-called smaller value in the top box and the larger value in the second box for the x-intercept. So you would put this one first in this problem and then this one. All right, now the y-intercept, much easier to find. So finding x-intercept is kind of involved too, right? Finding y-intercept is relative to how difficult those other steps were. The y-intercept is much easier. You get to just set x equal to 0. So we're literally plugging 0 into the function, and you can use whatever form of the function you want. I'll use the standard form, even though the form they gave us at the very top would be easier, but it doesn't really matter. So I'm getting 0 minus 1 is negative 1. Following my order of operations here, so negative 1 squared is 1. And then 2 times 1 is 2 minus 5, so 2 minus 5, and then I'm getting negative 3. So my y-intercept is 0 comma negative 3. No calculator needed to calculate that. And that is every single piece that you will need to solve that problem. That is everything they ask for. All right. Next one, number 4 in the WebAssign. This is still 3.1. I'm going to go through this one a lot faster, just so you can have the solution and understand like what it should look like. But I am going to go a lot faster here. So what is the function? It's f of x equals negative x squared plus 10. Oops, I forgot the negative. Negative x squared plus 10x. Okay, so standard form, pull a negative off of the first two terms, which there are only two terms, so there we go. And then I'll take half of that linear term and square it, so that's the same as negative 5 over 2 squared, and that's 25. So that gets added and subtracted. So I'm going to have negative of x squared minus 10x plus 25 inside, and then I'm supposed to have minus 25 outside, except the minus, so I should actually have a plus 25 on the outside as well to bring balance. What? Sorry, one second. Okay, sorry. Okay, so why is it plus 25? Well, because this negative makes this 25 negative 25. So how do I bring balance to the equation? I add 25. Okay, now I factor this thing. I know it should be like x squared, something like this. And it should be a minus 5 inside. I know from looking right there. Or I could just go factor this thing. Okay, that's it. It's in standard form. It's opening downward because of the minus sign, and its vertex is at 5,25, and its maximum, yes, it has a maximum because it's opening downward. Its maximum, let me see how they ask it in this problem, or maybe they don't. Where is it? They don't ask for the maximum, but we could find, I mean, if we have the vertex, we can say the maximum, but they didn't ask for it explicitly. Okay, so the x-intercepts now. X-intercepts, I'm going to take my function and set it equal to 0. So negative of x minus 5 all squared plus 25 equals 0. Start solving for x. I got to unpack that x from inside the parentheses. First thing I do is scoot that positive 25 over. Now I'll divide by a negative 1, which is effectively going to make both sides positive. That's good. Now I'm going to have x minus 5 is equal to plus or minus square root of 25. But that's nice because that actually simplifies. So I'm getting x minus 5, still have the plus or minus there, and then square root of 25 is 5. Simplifies into a nice whole number. So my two solutions are x minus 5 equals 5, or x minus 5 equals negative 5, splitting around the plus or minus, right? This solution gives me x equals 10. This solution gives me x equals 0. Adding 5, right? Adding 5 plus 5 is 10. Negative 5 plus 5 is 0. So my two solutions are 10 comma 0 and 0 comma 0. So it goes through the origin. That means that that's also going to be my y-intercept, but we'll show that. All right, so again, it asks you to plug in the smaller value for the x-intercept and then the larger value. So this would be your first solution and this would be your second solution. Now the y-intercept is plugging in x for 0, plugging in 0 for x, rather. So negative of 0 squared plus 10 times 0, which of course is just going to be 0, so that corresponds to 0 comma 0. The x is 0 because I forced it to be, and the output was 0, right? So they're both 0. What's up, Kitty? All right. Now they ask for a sketch of a graph. They ask for the sketch of a graph. So you would, of course, I'm just going to do it by hand here. I need to go all the way out to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my vertex was at 5,25. I'm going to count. What am I going to do here? Okay, on their graph, they count by tens. I think I'm going to kind of cheat and do the same thing. So down here, this is 1, 2, etc., all the way up to 10, and this is 10, 20. So they've adjusted the scale just so that we can graph that vertex, because recall that vertex is pretty high y value. Okay, so my graph is going to look like vertex at 5, 25. So that's 1, 2, 3, 4, 5, 25 is like roughly there. I've got a y-intercept here, or rather an x-intercept and a y-intercept right at the origin. Another x-intercept there, and that's all I need. I'm going to connect, plop some lines out like that. There it is. Okay, and then they ask for the domain and range, right? Domain and range is going to be domain always, for these functions at least, is negative infinity to infinity. And my y values that are allowed, well, I have no bound on the going downwards, right? So I have negative infinity up to what's the highest y value? The highest y value is at 25. So that's negative with a bracket, with a square bracket. There we go. All the way up to 25. All right. .2. How many are there? Oh, I'm not going to be able to do all these. I will do some select few. Let me check something. Shoot. 9, 10, 17. Okay. All right. All right. So some end behavior stuff for number 1. We've got a part A, y is equal to x cubed. So they're not writing it in function form for some reason, but that's okay. We don't really need that for this problem. Yeah, instead of f of x, they're using y. So as x tends to infinity, y is tending to where? And as x tends to negative infinity, y is tending to where? That's what we need to answer here. We need to know the shape of this graph. Well, x cubed is an odd degree, so it's the legs point in opposite directions, down then up or up then down, right? Since it's positive, we know it's got to be this one. So looking on the right of the graph, as x tends to infinity, that's the right side of this graph, the graph is pointing up. Looking on the left, where x is tending towards negative infinity, that's the left side of the graph is pointing down to negative infinity. Okay. Having these pictures helps, right? And understanding that this means right side, and this means left side. All right, now part B is y equals negative 7x to the 4th plus 17x plus 600. Okay, let me close this door. Okay. So having the picture on the side is really going to help here, right? We've got a even degree. We've got an even degree function, well, or equation, whatever. In this case, they've written it as an equation, just a polynomial, not technically a function, I guess, but it doesn't matter. The point is, it's got an even degree, right? That 4. So it's either the legs point in the same direction, either both pointing down or both pointing up. Since it's got a negative leading coefficient, it's got to be this one. Okay. The 7 has nothing to do with it, really. It's about the sign of it. It's about the even or oddness of the degree, that exponent, and the sign of the term that's attached, the coefficient rather, that's attached to that x with the highest exponent. All right, so we have this general shape, and we know that on the right side, it's pointing down. In fact, it's pointing down on both sides, right? It's pointing down on both sides. So anytime you're dealing with an even degree polynomial, both of your answers should be the same. They're either both negative or both positive. All right. Number 2 says, if C is a 0 of the polynomial, then consider the following. Yeah, okay. If C is a 0, that just means that P of C is equal to 0, right? And then that means X minus C is a factor. All of this stuff is just definition stuff. And then C is an x-intercept of P, or really the graph of P is the appropriate way to say that. Not just P, but the graph of P of X, or just P, whatever. Okay, yeah. So these are all equivalent statements. These all pretty much say the same thing. If C is a 0 of the polynomial, that means that C is like a solution to this equation. That means that it's an x-intercept, right? We've been doing that. We did it in 3.1 just a second ago, using that idea. And of course, that also means that X minus C is a factor of P of X. This is just definition stuff. All right, now we've got some transformations. So X squared minus 4, they want you to graph that. That's just scooting down by 4. Number 3. So this is just going to be a parabola, the standard parabola, but scooted down. Recalling how that worked in chapter 2, minus 4 outside, that means scooted down by 4. So that's what you'll be looking for there. And then we have part B is Q of X. This was supposed to be P of X. There we go. Q of X. Now the minus 4 is stuffed inside the parentheses. That's still a parabola though, because of that squared term. But this time it's scooted right. So remember, by 4, scooted right by 4 that way into the positive X axis. Remember that whether the number being added or subtracted was outside or inside the base function had an effect on whether it was scooting up, down, or left, right. All right. C says P of X equals 3x squared plus 2. So that's going to be a parabola like this, stretched vertically by 3 and shifted or scooted up by 2. So we'll be looking, actually, honestly, the easiest thing to look for in these multiple choices, look for the one that's shifted up by 2, because they've got shifted down, shifted left, shifted right, and shifted up. So there's 4 choices there. Okay, so D, they call it P of X again. P of X equals negative of X plus 2 all squared. That's going to be, so I'll write this one here, a parabola flipped over, so the negative outside means flipped over the x-axis and scooted or shifted left by 2. All right. Now, number 4 is the same, except that they're all cubic graphs. So number 4 is the same idea, except instead of all these like little parabola shapes, you're dealing with the so it's same, but with this base shape. Ooh, that's ugly. Let me redraw that. Same, but with this base shape instead of the base shape of the parabola. All right. I'll go ahead and tell you these questions are not really emphasized on the test. The test I'm emphasizing more the stuff that we've done more recently in class. The 2, 3, and 4 are more like kind of like showing how you can use ideas that we've investigated in the past to graph these polynomial functions, but I'm more interested in you knowing what we covered more recently, like explicitly in 3.1 and 3.2. Okay, so number 5 is a function, or polynomial function s of x equals 1/2 x to the 6th minus 2x to the 4th. They want the end behavior. Well, since it's even and both legs are, since it's even and the leading coefficient is positive, then both legs are pointing up. So it's going to have this sort of general shape. It's probably going to do some wacky stuff in between, maybe like like a W shape maybe or something. But the point is that the end behavior, both legs are pointing up. So both of those would be pointing up to infinity. And then it says to match the polynomial function with one of the graphs. Well, you'll see that there's only, oh wait, never mind. I was going to say, wait, hang on. Okay, there are 2 answer choices that have both legs pointing up. So we have to find the x-intercepts to be sure about which one is right. So we should take 1/2 x to the 6th minus 2x to the 4th and set it equal to 0. You can pull an x to the 4th all the way outside. That's allowed. This is going to leave me with that. Pulling an x to the 4th all the way outside. That's legitimate. You can do that. And then I can set each of these equal to 0 independently. Now, clearly, this one is just going to give me x equals 0. The other one, not so clear what it might give, so let's solve it. Add 2 to both sides. Multiply 2 on both sides now. Square root both sides. Plus or minus. Nice. X equals plus or minus 2. So we have 2 unique x-intercepts here at -2 and 2. And we also have this one, which is 0, 0, right? 0, 0, with multiplicity 4. So we multiplicity 4. So we expect it to bounce off of this x-intercept and probably hang around there for a while. So I'm expecting the leg on the left to be pointing up. It's going to come through -2. It's going to come bounce. So this is like the x-axis here. Hits that -2 spot. Then it's going to come back up to the 0. So here's my y-axis. Back up to 0, bounce off of that, and then come back and go through 2. Hitting all 3 of those x-intercepts, but bouncing off of the this one. So it looks like, so that's enough to narrow down the answer choice to the right one. Number 6 goes similarly, except it's even easier because, oh no, it's not, never mind. There's still, okay, so it's, you'll see that just by looking at the end behavior for these problems, you can narrow down the multiple choices to just 2 choices, because number 6 has an odd degree, so you should be looking at the WebAssign when you watch this video later. This is number 6 in 3.2. It has a negative coefficient and it's an odd degree, so I know that it should be behaving like with its left leg pointing up and its right leg pointing down, which if you look at the answer choices, there's only 2 that do that. There's only 2 that do that. For me, it's the 4th and the 5th answer choice. Well, actually, it depends on how you count them, but there's only 2 that have the end behavior of left leg pointing up and right leg pointing down. So what you would do is find the x-intercepts, similar to the way I just solved the previous problem. Find the x-intercepts to figure out which one it actually is. And you should find it's the less wiggly looking one when you do that problem. All right, number 7 is just a sketch. It's already factored, so you should be able to set that function equal to 0, find its x-intercepts. You'll find that it has x-intercepts at 4 and -3. So that should be enough to help you find the graph. Find the graph that has x-intercepts at 4. Wait, did I say that right? Yeah. 4 and -3. And also figure out whether its leading term is positive or negative. Hint, you should see that it's negative, right? Because you'll have negative x times x. That gives you negative x squared, so it should be pointing down. All right, number 8 and 9, so... Okay, I've worked in problem like 8 and 9, I think. I'll just go ahead and work it. I'll just go ahead and work number 8. Maybe I'll work number 9 too. P of x is negative of 2x minus 1 times x plus 1 times x plus 5. Okay, oh, hang on, what a sign, don't. All right. Leading term is going to be 2x times x, but also times that -1. Don't forget that negative up front. That negative up front is going to flip the sign on my leading term, so I'm going to get negative 2x cubed. So it's a cubic and it's got an odd degree, so I know it should be shaped like this. All right, is that enough to actually find the answer? Let's go peek at the solutions. No, there are 2 that act like that. So we've at least narrowed it down. Let's see. They have different y-intercepts. Can we be lazy and just find the y-intercepts? I think so. How do you find the y-intercept? Well, you take that negative up front. Don't discount that. When that negative's up front, you got to make sure you involve that. And then you take the product of all of the constant terms. So another -1 from this, and then times 1, and then times 5. And that's giving me 5. Right, 1 times that's positive 1 times 1 times. So I've got a y-intercept at 0, 5. Now go look at the answer choices. Only one of them goes through 0, 5. One of them goes through 0, 5. One of them goes through 0, 10. For the ones that point down like that. So you'll be looking for the one that. So. They're counting by 20, so they're counting by 20. 20 is all the way up there. You're looking for the one that's coming down like this, and then going up just through 5, and then going down like that. The other answer choice that looks like this, with left leg pointing up, right leg pointing down, its y-intercept is much higher. So we want the one that's going through that point there, 0, 5. So we did all that without having to find the x-intercepts, which was nice. That's kind of a sneaky way of solving that. I'll go ahead and solve number 9. Number 9, I have p of x equals negative x cubed plus 3x squared plus 10x. They want all of the x-intercepts. They want all of the x-intercepts, so I'm going to take this thing, set it equal to 0, and solve for x. I can pull a negative x off, leaving me with x squared minus 3x minus 10. And let me just rewrite. Pull a negative x off, x squared minus 3x minus 10. And then I can say, oh, wait a second, this factors into x minus 5 and x plus 2, just by knowing how factoring quadratics work. And I set each of these equal to 0 independently. Negative x equals 0, x minus 5 equals 0, x plus 2 equals 0. This, of course, it just gives me x equals 0. This gives me x equals 5. This gives me x equals -2. 0, 0, 5, 0, -2, 0. No multiplicity issues here, right? They were all just straight up equations, no multiplicity problems. So there's my 3 x-intercepts. And the way they want the answer is they want you to just say x equals. So you would say x equals -2. Well, I guess if I put them in numerical order, there they are, -2, 0, and 5. You don't have to put them in order, I don't think. I don't think they care if you put them in order, at least in this case. And then you have to find the graph. But you know it's cubic and it's got a negative sign, so left leg should be pointing up, right leg pointing down. So that narrows it down to 2 choices. And then you'll go make sure that it's going through these 3 x values at -2, 0, and 5, and that should be enough to narrow it down. Okay, so that is all of 3.1 and 3.2, all of the homework. I didn't work explicitly every single problem, but I worked most of them. So this should be an excellent review for you before the exam. Alrighty.